¿Cómo está? Yesterday, we talked about the quadratic formula a bit. Really, we talked about the discriminant. Today, we're actually going to use the quadratic formula to solve quadratic equations. So first, make sure you've watched the notes from yesterday. Otherwise, you're going to be pretty confused today. So little reminder as we get started. Standard form, super important. To do anything that we're doing today, you have to have standard form. And here's what it looks like for a quadratic equation. 0 equals ax squared plus bx plus c. That's standard form. Ax squared plus bx plus c. And remember, standard form means we go from greatest degree to smallest. So degree 2, degree 1, and if you have a constant, there's no degree there. Another reminder from yesterday, quadratic formula. I won't sing it this time. If you want to hear me sing it, go to the other video. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, this is on the bottom of your formula sheet, so you really don't have to memorize this. Lucky you, I did when I was your age, so feel lucky. All right, we are going to solve. Another way of saying solve, we might say find the solution set. That's the same thing as solve. Now, you might recognize this. Again, hopefully you saw yesterday's notes. This is an example from yesterday. And yesterday, we found out that we're supposed to have two real solutions. So let's find out if we were right. Okay, we are already in standard form. That's always step one. Are you in standard form? 2x squared plus 3x minus 5, yes, that's standard form. So that means a is 2, b is 3, c is negative 5. Okay, we're going to fill in this equation with everything we know. Use parentheses. So, x equals negative, oops, silly me, I wrote b. We want to write the actual value for 3. So x equals negative 3 plus or minus the square root of b squared, so that's 3 squared, minus 4a is 2, c is negative 5. And all of this is over 2 times a, which we said is 2. That is a monster of a problem. Don't panic, we can do this. Just remember PEMDAS. So let's deal with some parentheses first. So x equals, well, nothing's happening here. This is just negative 3. Plus or minus, square root. 3 squared is 9. Minus, okay, negative 4 times 2 is negative 8 times negative 5. And 2 times 2 is 4, so this is all over 4. All right, let's see if we can simplify it even more. Well, negative 8 times negative 5, that's positive 40. It's really important that you double check your signs, because that's where I see a lot of problems happening. All right, well, 9 plus 40, that's 49. Now I'm going to pause here for a moment and point something out. Yesterday, we just did this part that's under the radical. Do you remember what that's called? Yeah, the part under the radical is called the discriminant. So notice our discriminant is greater than 0. So we are expecting two real solutions. And this formula should give us our solutions. Okay, I want to point out, oh, I forgot something. So we got this plus or minus, and everything's almost as simplified as we can. You know, square root of 49 actually gives us a nice number. So type that in your calculator, you should find that gives us 7. Okay, that's as pretty as we can get. But we're going to split it in two. So notice we got the plus or minus. That's what this symbol right here means. It means plus or minus. So we're going to see what happens when we add and what happens when we subtract. So write it exactly as it is, negative 3. We're going to see what happens when we add 7. And then over here we're going to do the same thing, but we're going to do the minus 7. See what answers we get. All right, here on the left, negative 3 plus 7 is 4. 4 over 4 is 1. Over here on the right, negative 3 minus 7, well, that is negative 8. Oops, negative 8 over 4 is the same as negative 5 over 2, which is, another way of putting that is negative 2.5. So we were right. We got two real solutions, x equals 1 and x equals negative 2.5. Those are the solutions to this. All right, let's do two more examples on our next page. Here's example number 2. Okay, remember, step 1, is it in standard form? So you might want to write this to remind yourselves. Ask yourself, is it standard form? Yes, x squared minus x plus 10, that's standard form. Oh, next question is, what's a? Oh, right, if we don't have a coefficient, there's a 1 hiding there, so a is 1. Oh, shucks, similar problem with b. What's b? Again, there's a 1 hiding there, so b is negative 1. And c is 10. Okay, so look at your quadratic formula. X equals negative b, so use your flippin' parentheses or else I'll come and haunt you. When I die in 80 years, I'm going to come and haunt you if you don't use parentheses. Negative b, yes, our b is already negative. We'll deal with that in a moment. Plus or minus the square root of b squared minus 4ac. And that's all over 2a. Yay. All right, let's deal with some parentheses. Okay, if you have a negative 1, that's really a positive 1. Okay, negative 1 squared, and negative 1 is the same as negative 1 times negative 1, so that's positive 1. Minus negative 4 times positive 1 is negative 4. We're going to keep that 10 there for a moment. And then on the bottom we have 2 times 1, that's 2. Okay, negative 4 times 10, that's negative 40. That's the only thing I changed. All right. Well, 1 minus 40, that's negative 39. Now here's the thing. This is a problem. This negative is a big, massive problem. We have a negative under the radical. That's what this funny symbol is called, the radical. We have not gotten to the point in our math careers where we know what to do with that. Go on to Algebra 2. We'll talk so much about that in Algebra 2. But we're just going to stop there. If you have a negative under your radical, no real solutions. For those of y'all who are curious, oh, Ms. Stratman, what in the world? No real solutions. But I see there's got to be some sort of solution. They're called imaginary numbers, complex numbers. Don't worry about it. I know it sounds like I'm making stuff up. I'm not. Again, go to Algebra 2. You'll find out about complex numbers. It's really interesting. But for Algebra 1, we're going to stop there. Let's do one more. Make sure we got this nice and pat. Okay, is this in standard form? Absolutely. A is, well, remember, if there's no coefficient in front of your variable, there's a 1 hiding there. A is 1. B is 6. C is 9. Cool. Let's use that quadratic formula. Woo! X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And yes, I've memorized that thing because I use it that much. Let's do some simplifying. Okay, negative 6, that should be pretty obvious, plus or minus square root 6 squared, that's 6 times 6, that's 36. Negative 4 times 1 gives me negative 4. We keep that 9 for a moment. 2 times 1 is 2. Let's keep going. Okay, negative 4 times 9 is negative 36. Nothing else changed. Well, wait a second. Let's pause for a moment and think for a second. 36 minus 36, that's 0. So notice the discriminant, because remember the part under the radical is called the discriminant, equals 0. If we look back at yesterday's notes, that means we're going to have one real solution. Cool, that's what we're expecting. One real solution. Okay, negative 6, well, it makes no sense to write plus or minus 0. I mean, why write plus 0? You don't need it. So it's really just negative 6 over 2. Well, that means if we plug that in our calculator, if we ask ourselves what's negative 6 divided by 2, that means x is negative 3. Hey, that is one real solution. That's what exactly what we said we thought we would get. Okay, you've got some practice to do, and so that handout you got, glue it into your notebook. Get to it.